This video will be about trig quadratics with double angle and calculator. Some things to remember for this topic are the double angle formulas, which you will pretty much have to memorize for this topic and others, of sine 2 theta and cosine 2 theta, and remember that theta may be switched out with x or different variables, but it always means the same thing. You will also need to remember the angle sum formulas, and that for sine it goes sine, cosine, cosine, sine, and for cosine it goes cosine, cosine, sine, sine. And when using cosine, you need to use the opposite sign of what is given, and as Mr. Reader likes to say, it is the cos opposite. You also need to use the equation of sine squared plus cosine squared equals 1, and that this equation may be manipulated in many different ways, such as cosine squared equals 1 minus sine squared. You also need to know specific locations on unit circles, such as pi or -1, 0, and remember that the coordinates for these points on unit circles will be known as x is cosine and y is sine. You also need to remember what to do with or without a domain, and with a domain you will need to cross off any parts the answer shouldn't be in on the unit circle, and without a domain you need to include all possible answers. So you'll need to have your answer plus 2 pi n, which includes all possible answers to pretty much infinity. You also need to remember the calculator commands, and you will need to use inverse sine or arc sine or inverse cosine or arc cosine, which measure the length of the arc that you're trying to find on the unit circle. And you need to remember that the numbers inputted into the parentheses must be between -1 and 1, or else you get an error, and the numbers that are below -1 or above 1 will not be answers to the problem. And always remember that your calculator needs to be in radian mode. Alrighty, jumping right into the first problem, we first read the directions that say, solve the following for theta. Use exact values when possible, otherwise round to the nearest thousandths, which is the third place after the decimal. That's just in general Mr. Reader's rule. So first let's start off with the angle sum, because from the angle sum you can either get an answer that is sine or cosine, and the cosine 2 theta we can use to find an equivalent form of it and have sine or cosine just to make one trig function. So let's just copy 2 cosine 2 theta on the left and do equals, I like to put it the angle sum in brackets and do sine theta cosine pi plus cosine theta sine pi. Just alternating the theta and the pi. And don't forget the -1 on the end because that will drastically change your answer. Okay, so when looking at angle sum and looking at cosine of pi and sine of pi, we look at a unit circle. And on the unit circle, pi is located directly to the left. That point on the circle is also known as -1, 0. And we also know that cosine is the x-coordinate, which is -1. So over cosine of pi, I would just put -1. And then sine of pi would be 0. And so over sine of pi, I would put 0. So technically cosine of pi is -1 and sine of pi is 0. And since you're multiplying cosine of theta and sine of pi, this whole thing is just 0. So you can just cross that out. And so rewriting this thing would look like 2 cosine 2 theta equals -1 times sine, which would be negative sine theta. And then don't forget that -1 on the end. Okay, so an equivalent form of cosine 2 theta that we can use to just have one trig function would be 2, well, don't forget the 2 in the front, and 1 minus 2 sine squared theta. So 1 minus 2 sine squared theta is just an equivalent form of cosine 2 theta, and we carry down the 2 just so that we can be able to distribute it, and then negative sine theta minus 1 on the right. So distributing, you get 2 minus 4 sine squared theta equals negative sine theta minus 1. And then I would like to bring everything on the left and put it on the right so that our 4 sine squared theta is positive when we factor. So just moving everything to the right, you get 0 equals 4 sine squared theta minus sine theta minus 3. Okay, and then this factors to 0 equals 4 sine theta plus 3 and sine theta minus 1. And we can tell that because this would be 3 sine and this would be negative 4 sine, which would make the middle term negative sine, just one negative sine, and the end term negative 3, and the first term 4 sine squared. So we can take these two terms and we can do 4 sine theta plus 3 equals 0, and sine theta minus 1 equals 0. When we set those equal to 0, we can find that sine theta equals negative 3 over 4, and sine of theta is also equal to 1. So starting with sine of theta equals to 1, we can find that on a unit circle, sine is 1 at pi over 2. Also, for sine of negative 3 over 4, we use our calculator and do second sine to get the inverse sine and do negative 3 divided by 4. So on your unit circle, sine is negative in the down 2 quadrants. So technically this arc has a length of 0.848, but we're measuring from 0 all the way over here. So we want to find this whole arc. So we would do 2. So we would multiply this by negative 1. So it would be positive. And we would subtract that from 2 pi. And you would get 5.435 for this angle. And then for over here, you would do pi plus your original sine negative 1 of negative 3 over 4. So you get 3.990 for rounding, because you would round that to 9 and then you'd leave a 0 at the end. Okay, and so this problem does not have a domain, so we would have to add plus 2 pi n to the end of every single one of these answers. So you would get, as your final answer, pi over 2 plus 2 pi n, 3.990 plus 2 pi n, and 5.435 plus 2 pi n. Those would be your 3 answers for this problem. Alright, so the second problem of this video is problem 2a, and let's jump right into the angle sum again. And just because the angle sum will tell us if we need to use cosine or sine in our double angle. So let's just rewrite the left side. 2 cosine 2 theta minus 4 equals 5. Carry the 5 in front because the 5 is technically for the whole angle sum. So it's 5 bracket cosine theta cosine 4 pi. And then this is where the sign changes, plus sine theta sine 4 pi. Oh, bracket. So, on a unit circle, 4 pi can be located all the way to the right because you go 1 pi, 2 pi, 3 pi, 4 pi. And it's also known as 1, 0. So cosine at 4 pi would be 1, and sine at 4 pi would be 0. So you cross off this side because sine theta times 0 is 0. And then you rewrite everything to 2 cosine 2 theta minus 4 equals 5. And then you can just do a parentheses now, times cosine. And if you look now, we see that we can just distribute, and we have cosine on this side, so we can do 2 cosine squared minus 1 to replace the double angle on this side. So we can rewrite as 2 times 2 cosine squared theta minus 1, and don't forget the minus 4, equals 5 cosine. Distribute, and we get 4 cosine squared theta minus 2 minus 4 equals 5 cosine theta. We could simplify that to minus 6, but we'll do that in the next step. We can just move everything over to the left and do 4 cosine squared theta minus 5 cosine theta minus 6. And then this all factors out to 4 cosine theta plus 3 and cosine theta minus 2. And we can tell that this is the right factoring because these two terms make 3 cosine theta. These two terms make negative 8 cosine theta. And what we want to find is 4 cosine squared minus 5 cosine minus 6. And so that is the correct factoring. Then we move on and we see that 4 cosine theta plus 3 equals 0 would be cosine of theta is equal to negative 3 over 4. And we also see that cosine theta minus 2 equals 0 and cosine theta equals 2. Right off the bat, we can see that cosine of theta equals 2 will not work because when inputting to our calculator and doing second cosine, which would be the inverse of cosine, if we type in 2, we get an error. And we get an error because technically 2 cannot be an answer. It is nowhere, it's located nowhere on the unit circle. So we can just cross this out. We will get no answers from cosine of theta equals 2. But we can get answers from cosine of theta equals negative 3 over 4. On the unit circle, cosine is negative in the left 2 quadrants. And we will be finding this arc and this arc. So when we type this into our calculator, we do second cosine, negative 3 over 4. And we find that that is 2.419. And then we do 2 pi minus that answer, and we get 3.864. So now that we have our answers kind of laid out, we can go back and check and see if there's a domain, and there is a domain. So we have a domain from 0 to 2 pi, including everything. So we can just say that our answers are 2.419 and 3.864. We do not need to add 2 pi n to the end because technically our domain is from 0 to 2 pi, so we can't include anything else over 2 pi. So these would be our answers for this problem.